Okay. So I'm going to start by, okay, so good evening, everybody. So I'm going to start by taking you through how I'll start with Jupyter. So since I already opened the navigator one time, then I don't have to keep going through the navigator every time. But I'll just go to here to, I think, sorry, I should share first. Okay, so I think everybody can see my screen. I'm having a conference. So basically I go here to the start window and I have Anaconda. So if I let the drop down menu come, you can go to Anaconda Navigator, and then at Anaconda Navigator, you can look for Jupyter. Okay, let's do that again. But the next time I'll just go to Jupyter Notebook. You see it's already there. So, but this time let's do it. You go to Anaconda Navigator. This green thing will come up. May take some time. It will come up. And then I go there and sorry. So there's this green Anaconda Navigator thing that should come up. Where I should try again. So I go here, I click Anaconda Navigator. Surely it shouldn't take this long. Okay, yeah, so this green thing. So it's going to come up, and then I choose Jupyter Notebook. The next time we meet, I won't go through this. I just go through Jupyter Notebook and straight up it will start. Once you use Anaconda Navigator, and then you don't have to go through it every time. Okay, so it will come up. Like we said, also you can use Google Colab. So you can go to research.google.colab and you can use Google Colab too. Okay. I think this, okay. I don't want this. So I go here and I choose Jupyter Notebook. The Jupyter Lab, this is not what you choose. You choose Jupyter Notebook. So I choose this. I click launch. So it's going to launch something on my browser. So usually it should just go to my browser straight. So I don't know what's happening. Let me click it again. Let me be a little patient and then I'll click it again. So I click it again. Okay. Yeah, so this is what I expected. So it takes you to your browser. At your browser, you have um, so I'll just be patient. Something will come up now. Yeah. Okay. So I can click on new, and I don't want a terminal. I don't want a console. It's not really a file I want. I'll just click on Python Sometimes you have Python kernel. So this is the one I want. I click Python. So it's going to give me opportunity to have a new file. It's untitled, so I can immediately rename it. For the most part, if you don't rename it immediately, you'll forget. I often forget. That's why you have untitled for. I showed you that 3 times before I forgot. Oh, why do I have this twice? Because I wasn't patient the first time. So let me kill this one. So this one. Okay, so I can start typing different things I want in the place. Well, let me do this. I'll go to file and I'll rename from untitled 4. I'll put today's date. April 23, 25. Okay. So what we want to do today is, the last time we looked at conditions statements. So if, elif, else. Okay. So we saw this one with if the temperature is less than 0, you are solid. If the temperature is greater, okay. We mentioned that you need to do indentation. Indentation helps you to know which part belongs in the same block. If you are writing something in C, you do something like this. If something, and then you can open a bracket to let it know that these are the things it needs to do. So if A is equal to B, then you can say A equals, let's do A plus equals B, okay? In C, you do something like this with the semicolon, okay? In Python, you don't do this. In Python, what you do is, for it to know that this A plus equals B, let's do something else outside. B equals 3 times C, okay? So in C, because you already put this, it knows that this braces, it knows that everything in these braces belongs to this if statement, okay? In Python, you don't do this. What you do is you put a colon, and to show that it belongs to this statement block, you indent it. Okay, so I indent it. And you don't have to put a semicolon. So this A plus B belongs to this block, okay? Belongs to the if block. So if A equals B is going to do this, and then this B equals 3C is not part of the block, okay? So even if A is not equal to B, it's still going to do B equals to 3C. So for instance, if you say C is 1, oh, sorry, let's do A equals 3C. Let's say C equals 1, B is, sorry, let's do this. Let's say A is 1, B is 2, C is 3. Okay. So if you run this code now, and you ask it to print A, what do you think is going to print? A is 1, and then if A is the same thing as B, it does A plus equals B, then A is 3C, and then it prints A. What do you think is going to print in this?
So my guess is it's going to print none.
Yeah, it's going to print 9. Yeah, it's going to print 9. Because in this case, A and B are different. You know why? Oh. Yeah. In this case, A and B are different. Okay. So A is 1, B is 2. So it's check if A and B are the same. It says no, so it doesn't go to this. It doesn't do this A plus equals B. Okay. Actually, this is a bad example. Let's make this 4. Okay. So if A is equals B, this is not satisfied. So it doesn't do this A plus equals B. It doesn't do this. This statement out is the same thing as saying A equals A plus B. Okay. So it's, if A and B were the same, it's going to add B to A. So in that case, it's going to do A is 4 plus 1, which is 5. And then this statement tells you to multiply that A is 3 times C. Sorry. What am I trying to do? No, let's do A is 3 times A. Sorry. Yeah, so in this case, it's just going to print for us 3. Okay. Sorry, yeah. It's going to print 3 for us in this case. So it will start. So here it will say, check whether A and B are the same. A is 1, B is 4. They're not the same. Okay. So it's not going to execute this. Okay. And then it's going to go here and say A is 3 times A. So 3 times 1, and it's going to print 4 for us. But the main thing is that this A is 3 times A is not part of this block. Okay. So in this case, it's just going to print 3 for us. Okay. If I change it and make it part of the block, the way I make it part of the block, if you are in C, you put a braces like this and a braces here, and everything within the braces is part of the block. In Python, you use indentation. So if you are indented together, then you're part of the same block. So this A equals 3A is not indented with this one, so it's not part of the block. Well, let's make it part of the block. Okay, now it's part of the block. In this case, who can tell us what to print? Look at the whole program. So A is 1, B is 4, C is 3. When it gets here, A and B are not the same. Okay, so it will not execute this, and it will not execute this either, because they're not part of the block. Sorry, because they are part, this A plus B and this A equals 3A, they're part of this block, and this block evaluates to false. Okay, so it will check whether A and B are the same. A and B are not the same, then everything in the block, it will not execute. Then this print A is not part of the block, it will execute it, so it will print 1. Okay. The other time, this A equals 3A was not part of the block. So once it finishes the block, it will still do the A is 3A and then it will print it. In this case, A is 3A is part of the block and the condition is not satisfied, so it will not print it. So our prediction is that it should print 3. Sorry, it should print 1 in this case. And if you execute it, you see it prints 1. The other case, it printed 3, now it prints 1. Okay. So it's very important how you indent. Actually, the Python, the interpreter will let you know if you did not indent properly also. Okay. There's some cases where you indented properly, but this is not what you meant to do. Okay. Still, you get the wrong answer, but okay. So let's look at how you write a loop, because sometimes, so let's say I want to write all the numbers from 1 to 100. Okay. You can do print 1, and then you can do print 2, and then you can do print 3, and then you can do print 4. Okay. And this is just going to waste your time doing print. Someone say, oh, you could just use copy and paste. Okay, we can try that, but this is just going to waste your time copying and pasting and changing every time. And you're going to make mistakes. I'm going to print 1 to 5, but this is going to waste a hell of your time. Okay. So a printer 1 to 5. There's another way to do it. So the way to do it is you can say for a counter, say I in range 5. Actually, this one should be range 1,5. Sorry, 6. I'll explain this to you just now. So I'll print I do shift enter. You see it's printed 1 to 5. Okay. So I use this for command. What this does is, for everything that you have here, okay, it's going to take each of them and do whatever is in this command for you to do. Okay, so you're just going to take each of them, do what is in the command for you to do. If in the command I had something like J equals I star 2, okay, I print I and I print J. Okay, it's going to print I, which is from 1 to 5, and J, which is the square of I. So you're going to see it's going to print 2 numbers. It prints 1, 1, 2 and the square, 3 and the square, 4 and the square, 5 and the square. So anything you put in the block is just going to do it several times. Okay. So a little bit about, so in general, you write a range like range B N. Okay. So what this means is starts from A up to, but not including B. Steps of N. Okay. So in this case, it will start from 1 up to, but not including 6. Okay. If you don't put a step, it assumes the step is 1. So if here I put 1, it will do the same thing. But even if you don't put 1, it will assume the step is 1. Okay. If you don't put anything for the, okay, so if you have two variables like this, two things, it will assume this is the first one, is A, this is B, and then the step is 1. Okay. If you put only one thing, okay, it will assume, okay, so it will assume A is 0, B is 6, and the step is 1. Okay. So if you just put one thing, it will assume that B is 6. It will assume A is 0, that the first thing is 0. Okay. So this that I've written range 6 is shorthand for range 0, 6, 1. It's shorthand for this. Okay. So Python allows you to do this. In this case, you see it started from 0 up to 5. Okay. Because it goes from the first one, it goes from A up to, but not including B. So it does not include B. This goes from A up to, but not including B in steps of N. So this is what it does. I want to take a simple exercise. Let's say you want to sum all the numbers from 1 to 1 million. Okay. Let's say sum all the numbers from 1 to 1 million. Okay. So one way you can do it, not the only way, is to write something. So let's call it my sum. Okay. I'll start, my sum is 0. Okay. Then I will do this. I want it to start from 1. I want it to end at 1 million. Okay. So I can do this 1 million. This is 1 million. All right. This is 1 million. And I can add a 1 to it. Actually, let's do it the best way to do it. The best way is to define n as 1 million. Okay. Okay. If I do this, you see I put a colon at the end of for I. If you do this, it goes to sum all the numbers from 1 up to, but not up including 1 million. So it's not going to include 1 million. So if I want it to include 1 million, I put n plus 1 here. If you like, you can put a 1 here. It's fine. Okay. So if you, this now will go from 1 up to, but not including 1 million and 1. Okay. And then I can do my sum. I add I to it. Okay. So this will give you the sum of numbers from 1 to 1 million. Okay. The next thing I'll do is, if you put here for it to print my sum, if you do print sorry. Sum from 1 to n is okay. If you do this, there's a problem with this. The problem is that every time it's adding up the sum, it's going to be printing sum from 1 to 1 million is my sum. This is wrong. So you don't want this to be in the for block. It should be outside the block. After it has done all the sum, this is when you want it to print it. So I have to move this outside the block. Okay, so it's outside the block. So it's going to do this. The first time it goes through the loop, my sum is 0. And then it's going to add, and I will be 1. So it's going to add 1 to 0. The next time, I will be 2. Okay, because it goes from 1 up to 1,000,001. The next time I will be 2, it's going to add 2 to the previous sum it had, which was 1. Okay, and then the next time it's going to do this and it's going to do that. So if you run this now, it will sum all the numbers, and it gives you sum from 1 to 1 million is this big number. Okay, there are a number of things you can do. Let's maybe reduce it to 100, and then I'm going to print each time the value of I, and then I'll print the partial sum. So it's going to print I. So first time it will be 1. The partial sum will be 0 plus 1. It will print it. Then it will print 2. The partial sum will be 1 plus 2. It will print it. So it will keep doing this. It just does it, 100 times. Okay. So when it started, I was 1. The partial sum was 1. Then I is 2. The partial sum is 3. I is 3. The partial sum is 3 plus 3, 6. Okay. I is 4. The partial sum is this 6 plus this 4. Okay. Then I is 5. The partial sum is 10 plus 5 is 15. So this is the way it works. So I give you a challenge. One of the challenges is to print the multiplication tables using nested loops. You can print the multiplication table using nested loops. Let's do that at the end. We'll print the multiplication tables using nested loops. Okay. The next one we want to look at is just the while loop. Okay. And the way it works is while a condition is true, it will do whatever is in the loop. Whatever you put here is in the block is going to do it while the condition is true. Okay. So you need to watch to make sure that the condition stops being true after a while. Otherwise, it will just keep on in the loop forever. Also, if the condition is never satisfied, it will not enter the loop. Okay, so if you look at this exercise that we have, count is 0 while count is less than 5, print count, count plus equals 1. So I'm going to use exactly this exercise. Okay, this exercise. So this is just going to print this number, this count. Okay, you just count how many times it goes through the loop. So let's do it and say count is 0. Okay, it's just counting how many times it goes through the loop. So we'll say while count is 0. If I say while count is greater than 0, it should do this. It should print count. Okay, and then count increases by 1. Okay. Who knows what will happen in this case? Who knows what will happen in this case? Yeah, who knows what will happen in
I
this?
think it will be unending because there's no rate there.
No, okay, you see count is 0, right? And I say while count is greater than 0. Okay. So the first time count is 0, it will go here and it will check whether count is greater than 0 or not. Okay. Count is not greater than 0. Okay. So it will not execute this because this will be 4. It will not execute it. So if I do it now, it will write nothing and this will just be it. Okay. So you see it did nothing because when it went through the loop, count, this condition was not satisfied. So it does not execute the loop and it just gets out. Okay. So it does not execute the loop. Okay. Let's do this while count is less than, if count is less than 0, it doesn't do anything also. If you say while count is greater than or equal to 0, sorry, less than or equal to 0, it will do this, but you just do it once. Because the first time it goes through, count will be 0, it will print count, and then it will increment count. Now, count is no more less than or equal to 0, then it will not execute it again. So if I run this, it will just print 1, and this will be all. Yeah, sorry, it will print 0, because the value of count is 0, so it will print once, and this is all. So while count is less than or equal to 0, so in this case, count is 0, it will print count, which is 0, and then it incremented count, and goes back to run the loop. But now when it's trying to run the loop, it finds that this condition is not met again. So then it stops, okay? So let's do what is in the exercise. We have count is 5, so print count. So in this case, it's going to print, at first count is 0, it's going to print, then it's going to make count 1, then count is still less than 5, it's going to print, then it's going to make count 2. Count is still less than 5, it will print until it gets to a point where count is 5. And count at 5 is no more less than 5. Then it will stop. So we do it. So count, it grows from 0, 1, 2, 3, 4, and then it stops. Okay. This is actually one of the things that people use to when you are making a graphical user interface, like you have something, a pop-up window, and you want the user to click OK or no, yes or no. Okay, so you use a while true here, and then you put a command here to break so that it kills the window once the user clicks this or clicks that. Okay. So in this case, it's just going to, it does this and this is it. Okay. There's something I wrote that you should not try. So said you should not try it, but let's try it. And you'll see why it's a bad idea. Okay. So this is a bad idea. Actually, you should not try it. I'll try it and I'll hope I can kill it. Okay. So I'll say count is 1, while count is greater than 0. So the first time count is 1. 1 is greater than 0. It will print it. And then it will increment count to 2. 2 is still greater than 0, so it will print it. It will increment count to 3. 3 is still greater than 0 to print it. And it will just keep on in this loop forever and ever, okay, until you find a way to kill it. So if I do it, I do Shift Enter. You'll see that it's running and running and running and still running. The reason I know it's still running is it has a star there. So it's still running and running and running. So I have to interrupt the kernel or restart the kernel. Okay, let me interrupt the kernel first. Sometimes that is not enough. You have to kill the kernel or restart the kernel. I click restart. Okay. Okay, so it cleared it. So it stopped. The asterisk that was there before went off. So it killed it. So this is a bad thing to try. So don't try it, but if you try it, you can kill the kernel or interrupt the kernel or do something. So let me write this as the wrong while loop. bad. Okay. Then if you have a loop, let's go back to for loops. If you have a loop, sometimes you want to you may want to stop when a particular command condition is met and just stop the loop altogether. Or you may want that if that condition is met, don't do anything, just go to the next condition. Just go to the next one. Okay. So yeah. So in this case, if you I don't know how many of you did this one. Okay. So you're trying to do something from in range 10. So from 0 up to but not including 10. So 0 to 9. So if this norm, you can use any variable here, is 5. So for testing equality, you use equal equals. You don't use equal. Okay? For comparison, norm and 5. If norm equal 5, it should print norm. Okay. And then I put a break here. This other one, instead of break, I put a continue here. Okay. What this break will do is when it gets to, if norm is 5, it will break and you get out of this loop completely. Okay. Out of this block, it will get out of it. Out of this loop, it will get out of it completely. So it will only write 0 up to 5 and stop. This one tells it that if norm is 5, so it will write for 0, for 1, for 2, for 3, for 4. When it's 5, yeah, when it's 5, what this block tells it that is that it should print this and it should continue and go to the next number. So when norm is 5, it's not going to get to this line. It's not going to print this norm because I'll put a continue statement here. Continue means go to the next one. So to go to norm equals 6. Okay. So immediately it hits continue. It will not break out of the for loop, but it will just go to the next one. So the next one in this case will be 6. It will go to the next one, which is 6, and execute it. Okay. So let me see if I can quickly do this. Okay. I still put this in the, okay. So this print norm is not part of the block. Okay. It's not part of the if block. So in this case, you will see it's just going to print. And when it gets to 5, it's going to print this norm is 5 and it will exit. Okay. So it went from 0, 1, 2, 3, 4. And then it said this is norm equals 5. Okay. And then it breaks, exits the for loop, and it doesn't get to this command anymore. And it exits everything. If you use a continue, you will see clearly that what it will do here for norm equals 5 is not going to go to this line. Okay, it will print this, but it won't print this 5 as it was printing 0, 1, 2, 3, 4 before. So let's do it. Okay, so you can see it printed 0, 1, 2, 3, 4. Then this is norm equals 5. You see, it did not print 5, but norm equals 5, and then 6, 7, 8, 9. Okay, so that helps you to know the difference between break and continue. This is an important difference. Yeah. Does anybody have a question before we try an exercise? You can unmute yourself, and then we can try an exercise. Yeah, if you have a question, you can ask.
Good day, sir.
Yes.
So, I just wanted to clarify for the break command.
Yes.
Is the essence just to terminate the other part of the loop? Because when you use the continue, it gave almost the same output, but just with the continuation of 6, 7, 8, and 9.
No, so the break means when it gets to that point, just get out of this loop completely. Don't continue to do anything.
Okay.
Just stop, get out. Once you find the thing, there's no point checking again. So just break, get out of the thing, and you're done. Okay. So you save computing time and everything. Continue means when you get to this number, instead of doing this print that you have here, don't do it. Just skip and go to the next number. So you just continue to do what you are doing. But for this particular value, skip, don't print this. Okay. So once it gets to continue, it will go from here and go back to this for loop and go to the next number. Whereas break will completely leave the place.
Okay.
Yeah. Okay. Try to get a number that let's print multiplication table using nested loops. Okay. So we'll print multiplication tables using nested loop. So it's going to print okay, 1 times something is easy, so we're not going to do 1 times something. 0 times something is easy, we're not going to do it. But we're going to do 2 up to 12 because that's what used to be at the back of exercise books when I was younger. Okay, so we'll just do for J in range. I'll start from 2 up to, but not including 12, 13. So up to 12. Sorry, up to 13. So this will do from 2 up to, but not including 13. So 2 to 12. Okay. And then sorry, let's do I first. Just makes sense. You can do anyone. You don't have to call it IJ. You can call it AB. And you can even call it anything you want. Just some, okay, for A in range. And then let's write the product. A times B. And then we are going to print let's use a formatted statement. So it's going to be A times B equals product. Okay. Okay. So it's going to do this. Let's put something here to say print I don't know, what did they do? 2 times 8 times table. I don't know if this makes sense. Okay. I'll put a column. Do this. Sorry. Okay. And then here also, when it finishes printing a particular one, I want to print a space. Or if you like a new line, or let's just print a space. Okay. So it's going to print. Yeah, so let's do this. So you see, you can nest the loops for A in range this, for B in range this. And even if B depends on A, you can still nest it and everything. So we do this. Oh, sorry. I was wondering. 2 to 13. Okay. So you started with 2 times table. And we can check 2 times 2 is 4, 2 times 3 is 6, is 24. Then it went on to 3 times table. 3 times 2 is 6, 3 times this, blah, blah. 4 times table. 5 times 6 times table, all the way to 12 times table, and 12 by 12 is 144. Okay. Okay, so I want you to do the exercise of a number guessing game. I think we need something from the next hour to be able to do that. Okay. Because the number guessing game, the computer will guess a number, and then you will try to guess the number that the computer guessed. So you write down the number, your number, and then if your number is, if the computer number is higher than yours, it will tell you that, it will say higher, meaning you should go higher. If the computer number is less than the one you chose, it should say lower, meaning you should go lower. Okay. Yeah. Usually the number of guesses you're allowed, maybe 5 guesses, and if you guess it right, correct. Yeah. So this is the part. So I hope we'll be able to do that soon. It's a number guessing game and it's just good to do. Okay. I want, so there are other exercises here. You can create this one also someone should do. Maybe you show us the next time. You create variables storing your height in cm, weight in kilogram. Last time somebody did this. Then calculate the BMI. Then decide and print out if you're underweight, normal, or overweight. Then you should adjust the code to read the height and weight from the user and report the status to the user. You can adjust the code to read the height and weight from the user. So you saw how to do that the last time. So this one we just did. You can print even numbers from 1 to 20. So this should be easy for you to do now. So please try to do this. Yeah, and then we can also do a number guessing. Number 6 is interesting. Try to do it also. Write a smart code that finds all the prime numbers from 1 to 1 million. It should be smart to know that it does not need to check even numbers. So 2, 4, 6, 8, 10, you don't need to check them for whether they are prime or not. Okay. So this will make the things faster. Imagine if you want to go from 1 to 1 trillion, okay, or 1 to hexatrillion or something. Also, you don't need to go from 1 to 1 million. Okay, so you should think about how to do it so that you can safely stop when you are checking all the prime number. Yeah, find all the prime numbers from 1 to 1 million. So it will take, so you start from 3, it will check whether 3 is prime. Then it will go to 5, you should skip 4, 5, and check whether 5 is prime or not. You should skip 6 and go to 7, check whether it's prime or not. Okay. So write a smart code to do this, and then, yeah. Okay. So I think we can go to the next hour, unless somebody has a question. So the next hour has to do with functions and modules. Okay. So when you type on your laptop sine, or your calculator sine 3.14, you're actually calling a function that does all the calculations to give you the value of sine, or to give us the sine of 3.14. Computers can basically only add. Okay. There's a way they can subtract, but it's really by addition. Okay. They can multiply also by multiple addition. So if you say 3 times 52, it's going to add 52 to 52 to 52 3 times. Okay. But if you do sine, so what does it do? Okay. It does some maths underneath. Okay. So there are people that have written functions, they call them functions, that if you provide, if you write something like this, is going to find the sine of 3.14. So we are going to see an example of how to write a function. So this is the way you write functions in Python. You do a def, function name, the argument, colon, and then the definition of the function. Okay? You may return something, you may not return something. You don't have to return something every time. Okay. But this is the basic way to make a function. Okay. So I'm going to first do a function that takes the square of any number. Okay. There is another way to do it, but using lambda functions. But we'll do this. You just take the square of any number. So let's go there. Yes, Damilare, your hand is up. You can say something.
All right. I'm sorry for taking us back.
Yeah.
The exercise now loop that you said we should create a number guessing game. Are we to
Yes. Are you to what?
Are we importing any function there?
Yes, you will need to import in random number generator. A number to generate a number, a function to generate a number randomly. Yeah.
Okay.
Okay. So let's talk about these functions, and you know more what we mean by saying you import a function or import a module. Okay, so I want to create a function now that any number you give to it, it will square it for you. So I'll go to define it as my square. Okay, and it's going to take your number, and it's going to, let's do the mundane thing. I'll do SQ is num times 2, and then it's going to return the square to you. Okay, so this is the definition of my square. So later on, if I want to find the square of 147, let's find the square of something we know already. We see that it works. 3 times 3 is 9. So if I do my square, 3, shift return, yeah, it gives us 9. Okay, let's actually put a print. There's a reason why I want you to put a print around it. With Jupyter, it doesn't matter. It's just going to do it. So it prints my square 3, the value is 9, it prints it. So even if you want a number that is very large, I do this, it prints it. Or if I want 0.1, it prints, it gives me the square. What if I make it negative? It prints it, it gives you the square. So you see, I don't have to know how my square works. Okay. And I don't have to write my square myself. I can ask you or Damilare or someone to write my square, because sometimes you don't have time to do many things. So you can just ask somebody, write this function for me. I want to use it. Write this for me. And also, because of Python, the community is large. Many people have written many functions. When I was younger, when I want to do something, I will try to write the functions myself. Nowadays, I found that if you go online, make a Google search, many people have already done many of the things that you want to do, like simple things that you want to do. Many people already either experienced the problem and did them already, and you can just use their modules. Okay. So for instance, for sine of 3.14, you don't have to do it yourself. Some people already did it, and you can just use their function. We'll see how to use their function in a little bit. Okay. Okay. If I also want to, if it's even something more complicated than this, that is hard for me to wrap my head around, no matter how complicated it is, you can just define your function and you pass the argument into it. Okay. So let's do the one with the example that we have here. Okay. So in this case, any name you pass to it, which is a string, if you just print it. Actually, it doesn't have to be a string. Anything you pass to it, if you just print hello and print the thing. This is what this code does. It returns it and then you print it. Okay. So let's do this. So I'm going to take the listing and I'm going to okay. Okay. So okay, we don't have to have this here. Okay, so if I do this shift return, the greet function is there. Okay, so I can say print greet and I'll let's put Alice just like it was there. Okay. So you just say hello Alice. Okay. But if you do something like, because I know how the function looks like. If I say print 4, see, it's going to say hello 4, you know, because whatever you pass to it, it actually does not check whether it's a string or not. It returns the format statement, and I pass the format statement into greet. Okay. If I just do greet Alice, what will it return? Okay. If I just do this, you see, what it's actually returning is exactly this format statement. This is what is returning. And then I am the one that's trying to print it. Okay. So the correct way to use this would be something like this. So you see here that this one has quotes around it. Okay. Whereas the previous one, when I put a print, okay, does not have a quote around it. Okay. So it actually returns just exactly this, and you can print it. Okay. So this is the basic way to use arguments. You can print more than one, you can do more than one. For instance, if I define area rect, okay, I want to pass the breadth and the width to it, okay, and I will say area equals b times w, and I can return area. Okay. So you can do it this way. So I do this, and I can say area. So let's print area of rectangle. That is 2 by 3, and it returns 6. And also, if I want to know how much paint I need for a rectangle that's 2 by 3, let's say I need 5 liters per square meter. No, that's a lot. Let's say I need 2 liters per square meter. Okay, then I can just say paint needed. Sorry. Is 2, and then I find the area of the rectangle, 2 by 3. So I multiply, so the paint needed is 2 liters per square meter, and then I multiply by the area of the rectangle, which is 6. So I can do this, and I can then print paint needed. So I do this. What's up? Area rec. What did I call it?
There's T.
Rect. Yeah, there's a T. Thank you. Okay. So it's exactly 12. Okay. So the interesting thing is Python does allow you to define some of this as default, to put default values into some of this. But there's a rule about it. Okay. I cannot make this default. Okay. I cannot, okay. There's a rule about it. So this one, I can use the default value for this. Okay. So meaning, if I don't put the width, I just say area rect and I put 6. Okay. It will use B to be 6. Okay. B will be 6. And then W, it will assume a value of 2 there. Okay. So let's redefine this way. Okay. So if I try to print area rect 6, because I didn't supply the width, you're just going to use 6 and the default width, which was 2 here. Okay. So when I defined it, I put the default value there. So then you're just going to use 6 times, and it's going to give you 12. Okay. So it allows you to put some default there. But you have to be careful because you can't put a default for the first one and no default for the second one. Okay. Because if you pass only one variable, okay, for instance, if I do this, I put the default for the first one, but not for the second one. Okay. This is a problem. Okay. The reason is because if you call the function with only one variable, it will not know, with only one variable, it will not know what value to put for W. Okay. So it says syntax error, parameter without the default follows parameter with the default. So the ones that have a default have to follow all the ones that don't have a default. So I can do this, and I can put a 9 here, default, so you can do this. So then when you make a call, if you like, you can put both B and W. If you like, you put only B. So if you do something like print like this one now, yeah, like this one now, it will print 54. But if I do the same thing, shoot. If I do the same thing and I put 6 and I put 5, okay. Now it will not use the default value because I put exactly what it should use. So I do this and it prints exactly 30. Okay. So this is one interesting thing about using default values. When I was using Python, I got confused because I will see the function that I'm trying to call, like this one, and I will see this. I will see that it's taking 2 variables, B and W. Okay. At that time, I didn't know that W equals 9 means this default. I'll see 2 variables, and then I'll see calls in the program that is using only 1 variable. So I'm like, how? Maybe there's a different function that does this. No, but it's because of default. You can just pass 1 variable, and it will also use the default for the other one. So you can do this. So this works in Python very well. Okay. The other thing now is, let's say somebody has written a function for you. Okay. How can you use the function they have written? So let's say I'm professor, or I have people that are working together, and we distribute the work. You write the function to do this. You write the function for exponential. You write the function for sine, and you write the function for cosine. And then I want to use everything together. What can I do? Okay. One simple thing is all those functions, they can put them together in a file and call the name of the file my maths.py. Okay. they can put everything in a file and call the name of the file my maths.py. Okay. Then once they do that, all I have to do is I could say import my maths. Okay. And all the functions they have in there, it will import it. So let's say in maths.py, they define the function. Let's call it sine of x. Okay. They defined it, and the way you will define it is sine. Let's do a simple one. Is x minus x cubed over 3 plus x that's 5 over 5. Okay, so you define it this approximately. Okay, and then you can have another function exponential of x. These are all, this will all be in this file, my maths.py. So you define the function. Okay, so you say, oh sorry, I need to return. And then exponential also, you can define it and say my exponential equals 1 plus x that's the 2 over 2 plus let's say you have a function called factorial 2 because you need it. Okay. So you need to also write a function which is fac. So you can, this is actually one of the exercises to write a factorial function. So if I write a factorial function, I'll say, and then for j in range 1 to x plus 1, then I want to do my fac yeah, so I multiply that, and then at the end I return. Okay, so all this will be in the same file, and then you just import my maths, and then I can just call exponential. Import my maths, then I'll say my maths dot exponential say 3.2, and this will return exponential 3.2. Okay, and so this is how you do it. Somebody would have written the function, and then you just import it, and then you call it. And I can say my maths dot sine of 4.2 or 4.1. Okay, so you can just do it this way, and let's print it. Okay, I won't execute this because I don't have a file that I created already. Okay. But I'm going to show you one that some people already created. Okay, so there's a module called maths that people already created. Okay, and yeah, so there's an import maths. It's a math module that was created by some people beforehand. Okay. It has a function called sqrt that takes the square root. It has a variable called pi that gives you the value of pi. And you can also use it for sine and other things. So this we're going to use just now. So remember, some people already did the work to find the mass function. So you just first have to import it first, okay? So Python knows which function you want to import, okay? And then if you don't know all the functions that are in math, there's a way to get it. I'll show you in a minute. And then I can do print math dot sign, because I know sign is there. 3.14. Okay. So I do shift enter, and it gives me a sign of 3.14. The sign of 3.14 is close to pi. Sin pi is 0. Okay, so if you want to make it exactly 0, you can try 1.459. Okay. So you see it's almost 0. Okay. Because I know it's there. And let's also print math dot cosine 3.14. Sorry. Okay, if you print the sine and the cosine should be close to 1. Okay. Sorry, close to -1. Cos pi is -1. So you have this. So some people already wrote all these things. Not only that, we can find more like the value of pi. So print math.pi. If you print the value of pi, and let's print math.sine of math.pi. Okay. Because the value of math.pi is more accurate than the 3.14159 that I've put there. Yeah. So if you do all this, okay. So the value of pi is 3.14159, blah, blah. And sine of pi is 1.2, blah, blah, times 10 to the minus 16, which is almost 0. Okay. So this works as expected. If you want to know all the things that are in maths, first you import it like you have done. And actually, you don't have to import it here. You can import it at the beginning of everything you want to do. Okay. So in this cell now, I will use it and I will not import it. So let's do math.tan. I think there's a tangent. Tangent of math.pi. Okay. And let's print it. I hit shift enter and it gives me 0. Okay. What if I do tangent of pi over 2? Okay. So this should give you plus or minus infinity. Yeah, so it gives you some very large number. Okay. How do I know all the functions that are in math? I think you can do their, after you've imported it, you can do their math, shift return. It gives you all the things that are in math. So DRR. So if you look in it, so I do DRR math. So if you look there, there's a cos, which is arc cosine. Okay. A cos, a sine, a sine, a tan. So this is arctan 2. And if you keep looking, there's this CO, there's this copy sign, there's cosine. So you can see cosine. There's cos. There's degrees, cos, factorial. So they already wrote the factorial. F mod. Let's go down. There's log, which is natural log. Then there's log to base 10. There's log to base 2. So all that you get, there's sine, there's shine, all that you get by just doing DRR. Let me see what you get if you do help maths. Okay, so help math gives you more information. It tells you the people were nice enough to put a help in it. Okay, so it tells you maths and it lists all the function and tells you what they are. So for instance, a cosine x returns the arc cosine, measure the radians of x. If you keep going, a cos, a sine, a shine, a tan, arctan, nk, number of ways to choose k items from n item. So that's n combination k. Okay. So this is n factorial, k factorial, exactly what you would expect. copy sign, returns a float with the magnitude. So it just gives you a lot of things if you do help math. Yeah, error function and everything. So it gives you that. Okay. Yeah. So you can import and use function from the math module. And you can use exponential and different things. You can do different things. Okay. Any questions now before we go to the next chapter, which is data structures? We'll look at 4 kinds of structures, and I won't forget to also, please remind me not to forget to introduce NumPy, because this is very important part of scientific computing. Okay. Okay, does anybody have questions? Try to do the exercises, the simple exercises. Write a function to calculate factorial. I just showed you how to do one. Okay, any questions? Okay. So we can go on then to data structures. So we are going to do list. Ouch. We're going to do list. We're going to do tuple. We are going to do dictionaries. In that order. And then if I don't want to forget, I want to do NumPy array. Okay. Okay, so these are the things we're going to do. Data structure list, tuples, dictionaries, NumPy array. Okay. So in this case, data structure is just a way to store the data that you have. Okay. So and Python is really quite flexible. Okay. So you can have a list like we have in the exercises. So I can have a list which are called fruits. You can call it any name. Okay, you can call it A, you can call it B, but it's good to be descriptive. So I have a list with apple. Now Python allows you to use single quote or double quote. Banana, cherry. Okay. So, and is an ordered list, yes. So if I do fruits, 0. Okay, so this one is the 0th fruit. So it labels them. So this one is fruit 0, this is fruit 1, and this is fruit 2. Okay, it starts from 0, not 1. Okay, so if you say print fruit 0, you do it this way. It's going to print apple. Okay. If you want to print the whole list, you can also just say print fruit. I did something wrong. You can just do print fruits, and it's just print the whole thing again for you. Okay. And if I want to print cherry, what should I do? What should I do? I want to print cherry. What should I write?
Square bracket 2.
With 2.
What?
2. Index
Yeah.
of 2.
Yeah. So you can do this. Okay. The interesting thing is, let's say the list is very long and I don't remember cherry. Is it 46 or 49 or, but I want to print the last one. Okay. Python allows you to print to use -1. Okay. So even if you don't know anything about the list, you want to print the last one, just print fruits -1. We print the last one for you. So you don't even have to know how many things are in the list. You just want the last one, no problem. Let's use -1 to print the last one. And the first one is always 0. Okay. So the first one is 0, the last one is -1. The one just before the last one, like you guessed, is -2. The one just before the one before the last one, -3. Okay, so you can just keep going like that. But two that are most useful are fruit 0, fruit -1, the last one. Okay. So even if you have a list of gazillion things, you want to print the last one, just do that -1. Okay. What if I have a list? I want to know how many items in it. There's a function called length. Sorry, length. So you just tell you the length of it, and it will tell you in this case, the length is 3. Okay. If you already have the list and you want to add something to the list, there's a function called append. So the way you use it is fruits, the list. I want to append, and then the thing you want to append to it, let's append 3.0 to the list. Okay. This is the good thing about, beautiful thing about Python. The list, they don't have to be the same thing. So you can put a list of string, float, integer, anything you want. You can put them, okay? When we do C or Fortran, it's not so flexible. If you have an array and it's float, you want to keep everything float. If it's integer, you can't put float in it, you know? But in this case of Python, even if you have an array of strings, you can add float to it or integer to it, anything. So if I do shift enter, no problem. Let's now see what is in fruits. Okay, so let's print the list again. So now there's apple, there's banana, there's cherry. All these 3 are strings, they have quotes, and then there's 3.0, which I just added. You can remove anyone that you want. And there are many other things that you can do with this. You can splice. So for instance, if I, so I do fruits dot pop. I think pop is the thing. Okay, so I pop. So this is fruit 0, fruit 1, fruit 2, fruit 3. Okay, and then I did a pop of fruit of 1, so of banana. So I did a pop of it. So if you now look at fruits, you see, banana has been removed. I popped it. Okay. So I popped it out of it. And then I can also, okay, so I popped it out of it. And then I can also find the length. You see that the length is 3 because I already popped that banana out of it. Okay. So this is what you can do. With list. Okay. There are many other things you can do. You can splice it. The other thing I wanted to introduce is tuples. Tuples, they behave like lists. Oh, so for fruits, you see that for fruits, you see that we use square brackets for list. For tuples, we use this kind of brackets, curved brackets for tuples. Tuples are similar to list. You cannot change anything in the tuple. You create the tuple, You cannot add to it. You cannot remove from it. It's just there. Okay. And then finally, there's, so I can create a tuple. Let's create a tuple. I create a tuple which is my car, list of my cars. One car is 504, but let's write it as another car is Toyota. Okay, someone say these are car brands, not okay. Another one is let's do Nissan. Okay. Let's do Tesla. Okay. So if I say my cars dot pop, and I want to pop the last one, you see, there's no attribute pop. You can't pop the last one. Let's append to it. Let's append BYD. Okay. You cannot append to it. Okay. So it's just a stationary. So the last one we'll talk about with this is dictionaries. Okay. So you see, once I have the fruits and I want to access any element of it, I can say fruit 0. Okay. Or I can say something like fruits -1. Okay. And it will give me the last one and things like that. Okay. Dictionaries actually make things in certain situations easier than this. Let me give you an example. Suppose I have an Excel sheet where I have 0, I have a country, and I have the capital. Okay. And I have another country, the next one, let's call it Benin. What's the capital of Benin? I don't know, but is it Cotonou? Let's take another one, Ghana. Let's take Togo. The capital is Benin. Ghana. Okay, so I have a list like this. So what I want to do next with this list is, if I take the capital, if I take the country, I want to get the capital. Okay. So I don't want to say, okay, so if you are doing Excel, for instance, okay, this column, the first one will be A, and then the next column will be B, and then the next column will be C. Okay. So let's say I want the capital of Nigeria. Then first I have to look at the row number for the country. And then I will now look for C0. Okay. Once I find the row number. So for instance, say, what's the capital of Togo? So first I have to look and see that Togo is number 2. Then I have to look at C2. Okay. Or let's say in Africa, let's take Rwanda, then Kigali, take Kenya, take Nairobi. Okay, and you keep on going. So what I want now is, I want to just take the name of the country. Once you give me the name, I want to figure out what the capital is. I don't want it to be that I go through the list and first find this number. And then once I find the number, then I find C3. I want directly that once I say list and put Ghana there, it automatically gives me Accra. Okay. So the way we do that is we use a dictionary. And in this case, this Nigeria, Benin, Togo will be the key, and Abuja, Cotonou, Lome, Accra, Kigali, Nairobi will be the value. So you'll see how to do that just now. So let's call the dictionary countries. You open a braces to start it, and you close it with a braces. And all you do there is you put the country, and you put a colon, and you put the, the value. Okay. So the way they call it is this Nigeria, Benin, Togo, blah, those are the key, and then the value is this. So I'm just going to copy and paste this. So Nigeria, and it doesn't have to be a string, it can be anything. And then the value is comma for the next one. I put this. On, and then the value. Then I put a comma, and then I can do the same thing for all of them. Let's do for Togo. Okay. I hope you are also typing exactly also, because it's good for your learning to type the same. Okay. Okay. So in this case now, ordered. Even if it works as if it's ordered, just know that it's not ordered. Okay. So now I can say countries. If I put here Rwanda, okay, like this. Maybe I should have called it capital. Then you put the country in it. Yeah. Sorry, let's call it capital. Let's call this capital, not countries. Okay. So I call the dictionary capitals. So now if I say capitals, Rwanda, it's going to print for me exactly the value. Okay, so it printed exactly Kigali. Okay, so this is the key, this is the value. Okay, so basically what you do is you give the name of the dictionary. Okay, you put these braces, and then you put Q1, and then you put value. Okay, and then you put Q2, and then you put value 2. Have to be just like in this other case. It doesn't have to be string, 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 string. I can put 2. I can put Ibadan. Okay. So this, if you have put capitals and I put 2, it's going to give me Ibadan. And you can also do 2 is going to give me 2. And you can also do You can do something as crazy as this. Okay. So, oh, sorry, I didn't put a comma. Oh, yeah, let me put a comma here. Okay. So, if I put capitals 2 now, okay. So, it's not going to give me this. Sorry, it's not going to say this is 0, this is 1, this is 2. And then gives me and it's going to return the value of that key. Okay. So capitals 2, it gives me exactly value. Okay. What if I do capitals 3? Okay. So this is 0, 1, 2, 3. Let's try it. You know, just like list, we do all this. Let's try this. So there's an error because there's no key that is 3. If I do capitals Lagos, it's going to give me exactly the value here. So you give me exactly the value that I put in there. Okay. So this is very useful. As we go on, you'll see some of the usefulness of using a dictionary. Okay. And dictionary, you can call things in and out of order. You don't have to say capital 0, capitals 1. No. So you use the key to access it and then the value. I think there's a way also, if you know the value, to try to get the key. Okay. What if I repeat something? For instance, I put here Nigeria, Abuja, and in the past, it was Nigeria, the capital was Lagos. Okay. What will it return? Okay, we can try. You see, when I defined it, it did not give an error. Okay. You should try to avoid doing it. Okay. It gave Lagos, but it can give you anything actually. The reason it gave Lagos in this case is probably because this Nigeria Lagos was the one I put second, so it overwrote the first one that you have. But in Python, it's not guaranteed because it's really not in order. Dictionary is not in order, so you should try to avoid repeating the keys. Because if you repeat a key, then you don't even know what you'll get at the end. Okay, so I will avoid putting something like this there. Okay, so now if I do capitals Nigeria to give me exactly Abuja, because that's the only one there. Okay, so I mentioned that we'll do NumPy. So let's look at something. We created a list fruits. If I add fruits and fruits, what do I get? So let's say I say, let's print fruits. Is apple cherry 3.0. If I add fruits to fruits, let's call it fruits 2. Okay. And then let's print fruits 2. Okay. So you just repeated this fruit and did it twice. Okay. You can even just use star something. So if I do fruits 3 equals fruits star 3, okay. Sorry, and then let's print fruits 3. So you see, we just took fruits, apple cherry 3.0, did it 3 times. Apple cherry 3.0, apple cherry 3.0, apple cherry 3.0. Okay, so yeah. But let's say instead of something like this, what I wanted to do was to add two vectors together. So let's give an example. So I have a vector A, I write it as a list, which is 4, 3, 1. Okay. I have a vector B, I put it as a list, which is 2, 9, 11. Okay. And I want to add the two of them together. Let's call it C. It's A plus B. Okay. And let's print C. Okay. Who knows what I'm going to get? Who can guess? What do you think I'm going to get?
I think you're just going to get it. All of them will just be in a row. Just be like 4, 3, 1, 2, 9, 11.
Exactly. So that's exactly what you get. So you get 4, 3, 1, 2, 9, 11. This is what you're going to get. Well, let's say I'm in physics. This is not what I want to get. I want to get 4 plus 2, which is 6, 3 plus 9, which is 12, 1 plus 11, which is 12. This is what I want to get. What can I do? Unfortunately, you can't do that with plain Python. You have to use a module called numerical Python. Okay, so the name is called NumPy. Okay, so I'll do import NumPy. Okay, some people feel it's too much to type the full NumPy every time, so they say let's import NumPy as NP. Okay, what that means is instead of writing NumPy, like math.sign. Some people will prefer to write empty.sign. So here also, instead of writing NumPy.something, we can just use NP. So this is what import NumPy as NP helps us with. So you don't have to write this long name NumPy every time. This one is not as bad. There are some other names that are quite long, and you really want to shorten them. Okay. So what I'm going to do is okay, this list is already there, ABC, but I'm going to convert them to NumPy array. So I'm going to say NA equals NP, NumPy dot array. This is a function in NumPy. This you just have to NumPy array, and then NB is NP dot array, because I already defined the array B. Okay, so I do shift this and this. So now I want to print NA plus NB. Before then, let's define NC to be NA plus NB. Okay. And then I can print NC. So you see it prints 6, 12, 12, which is just exactly the addition that I want. As 4 plus 2, 3 plus 9, 1 plus 11, like vector notation. Okay. So it prints exactly that. Okay. I can also say what I want is I want a subtraction. Okay. So you can do that also. So you can print NA minus NB. Okay, so you can do that. Okay. Unfortunately, you cannot do a dot product. Okay. If you try to print NA star NB, what it will do is it's going to multiply 4 times 2, write it, 3 times 9 and 1 times 11. I'll write those things for you. I think this is what it does. So let's try it. So it's just going to do it element by element. So it's 8, 27, 11, which if you look here, is just 4 times 2, 3 times 9, and 1 times 11. Okay, so it does it element by element for you. I think NumPy has a way to do a dot product. And I think is if you do NP NA, comma NB. I think this should give you a dot product. So you can check it. And if you do I think you can also do something like NA dot NB. I think you can do something like this also. Okay. Okay. So it's NumPy. There's a dot function that takes NA and NB as vectors and finds their dot product. So you can do this. Yeah. It turns out NumPy arrays will be very important for us as you go on. Sum. Oh, you can collapse NA. I can sum all the elements of NA. So I can do NA dot sum. I think it's 8. So basically I'm summing all the elements of NA, which is I'm summing 4, 3, and 1. If you do NB dot sum, it is sum 2, 9, and 11, and you get 22. So you can do that also. Okay. But I think also it's important for you to know that if you do NA.NB, it's element by element multiplication. Okay. So any element by element multiplication. So yes, so another way to do the dot product in this case, you can do the element by element multiplication. And then you can sum it. And then you can sum this. And it will give you exactly 46. Because NA star NB is element by element multiplication. And then you sum everything and get 46, which is the dot product. Yeah. Okay. There are many things you can do with NumPy. We'll look at it next week when you do things related to machine learning. Yeah. Okay. Do you have any questions? Okay. So, yes, go ahead.
What else, sir?
Yeah.
When you wrote the vectors,
Yes.
by the time I wanted to do the dot product, you put NA. Must you put that NA and NB? I mean the NA.
No, but I don't want to use the same name as A and B.
Okay.
No, you can call it A, for instance here, I could have called it A tilde.
Okay.
Or A prime. I just don't want to use the same name.
Okay, I guess so.
But if you want to use the same, well, you can use the same name. Only that the A list will go away. You won't have it again. So I can say AP for A prime, and BP for B prime. You know, you can use any other name for it and do the same thing. Yeah. But if you think you are never going to use the list again, then you can just use you can do A equals this, and it will change the list to, yeah.
Oh, okay, yes.
Okay. Okay, so when we meet next, we'll talk about file handling and object-oriented programming. But I think also we'll talk about how you can communicate with the operating system directly from within Python. Sometimes you need to do some things from within Python and communicate with the operating system. Yeah. Okay. Thank you very much. Yeah. So I'll send the video to everybody. I'll update this file and put something on NumPy there and send it to you. Please do the exercises and then we meet again on Friday. Yeah. Thank you.
Thank you, sir.
Yeah,
Thank
sure.
you.